Hello everyone, welcome back to my channel. In today's video, we will be diving into the world of GitHub Copilot for infrastructure as code using Terraform and creating deployment workflows using GitHub Actions. Why to watch this video? So in this, we will understand Gen AI efficiency for infrastructure as code and deployment. We all know that Terraform scripts are challenging. If you are building the infrastructure on AWS, how complex it can be, especially when managing EKS clusters, VPCs, and setting up CI/CD automation. So we will see how can GitHub Copilot help. We will discover if Copilot generated code is accurate for your Terraform and GitHub workflows. So let's find out in today's video. We will be covering the topics. We will have a requirement for creating an EKS cluster. We will install the GitHub Copilot in Visual Studio and we'll use the GitHub Copilot to generate the Terraform code. We will also use the GitHub Copilot code for generating the GitHub workflows. And we will compare Copilot generated versus manual code as well. And at the end, I will just share some practical tips for how to maximize Copilot potential. The requirements for the EKS cluster. So at high level, I'm just covering like what are the requirements if you have to create an EKS cluster. You need a VPC with public and private subnets, and you need the tagging for the subnet so that it comply with Kubernetes requirements. And you need a EKS cluster so that you'll just deploy a fully managed EKS cluster which is ready for workload deployment. And to automate all this infrastructure as code that you have wrote in Terraform, you need GitHub workflow, so CI/CD automation. So this is the requirement. And to just explore GitHub Copilot, I choose this EKS cluster as a requirement, but it could be anything like you can create RDS, ECS, or any AWS resources. But as an example, I'm starting with this. The installation of GitHub Copilot on Visual Studio IDE. So I will open the Visual Studio on my machine as you can see it here, and I have to search for the plugin GitHub Copilot. So you can go to view at the top and click on extensions, and here you can search for the GitHub Copilot. You will find at the top GitHub Copilot extension and you can install it, and also it is provided by the github.com, so it is the official one. And when you install it, it will ask you for the sign up, so you have to sign up with your GitHub account. Once you sign up, you should be able to see this page. And also GitHub provides multiple plans for the Copilot, so this is I am using, which is the free one. There are paid versions also for the Copilot, and in this particular extensions you will find all the specific details and the features like how to use it, so ensure you can check all the features. And I have installed this GitHub Copilot chat as well. So now what is our requirement? We need to create a VPC code for our EKS cluster. So I already have this VPC code. Now we will see how GitHub Copilot will create it and try to compare the code. So what you have to do for that, you just click there and click on new file, VPC underscore copilot.tf. So we'll just create it, and as soon as you create the file here, you can see that it says that press command I to ask GitHub Copilot to do something, right? So I will just do that, and then you can ask anything. So this is like inline. While you are coding, you can ask any questions for your application code. So for now, I need a VPC code. So what I will need, generate me a VPC code using Terraform modules which has private and public subnet tags defined as per the Kubernetes requirements. So this is our specific requirements, and even we can provide it. The provider should be in US East 1 region. If you don't provide it, it will just take any random, but yes, you can provide the region wherever you are working on. So we'll just click on enter now. So here you can see that it is generating the code. It has uses the provider and then it uses the same modules and the name of your VPC and AZs, private, everything, and public subnet tags. And here you can see Kubernetes input output role ELB and here internal ELB. These are the tags that Kubernetes required. So at high level, this code looks good, right? Let's just click on accept and save as. And generally for the providers, we just create a new file for the providers and put all the code related to the providers in the separate file. So for now, we'll just delete this from here. Now we will do the comparison of the file which was generated by Copilot. So select for compare and compare it with the one which I have created it, right? So here you can see the difference. So you can see that it is using the same module and here they are using the version also that we are not using and this is all CIDR blocks. You can change it according to the requirements and the private subnets, public subnets, right? The only difference is, so here you can see that it is creating the VPC, but it is not creating the net gateways. And when you have to create the VPC, you need to say that how many NAT gateways you needed. Like if I don't provide this details, enable NAT gateway, single NAT gateway, then it will just create for three private subnets that we might not need it, right? So this is like a customization. When you are doing any demo or you things like that, you really don't need high availability for the NAT gateways. So things like that. So arguments option. So this is where I got this, but this is missing in the Copilot generated code right now. But if you want to have that code also, what we will do, you again go there, click on this and say I need only one net gateway. So let's see what it will do now. So here you can see that it has added that enable NAT gateway true or single NAT gateway. This is how the Copilot generates the code for the VPC, and it was like I would say 80% it was matching what we had in the manual configuration. So the thing is you really have to be explicit with all the requirements that you need for your Terraform code. If you miss it and if you just say very simple things, it might not provide you all the details that you are looking for. So now the next part is we need to generate an EKS code, right? So for the EKS code here, you can see that I have this module and I'm providing this all options. And now let's just create a new file and see how it generates the EKS code. So let's just click on new file and say EKS underscore copilot .tf. So I need generate me a EKS cluster using Terraform module with all the arguments provided and use the different module for managed node group. I don't want that both things to be combined. So this is your high level requirement. You need to generate an EKS cluster using Terraform module with all the arguments or with all the add-ons we can say provided and use a different module for managed node group. So just let's see what it will do now. So here you can see that it has generated the module code. The most important thing, the cluster version, it has taken the very old code. Currently we are on 1.31 and it is using 1.21, and because of this reason you might be able to see that it is saying that unexpected attribute, it is not expected because it has taken very old code which is very outdated and it is just not working. So here you can see that this is all not working and it's a very old code. So in this case, I would say that EKS cluster, so sometimes Copilot is not up to date with all of your features of the Terraform that it provides, and it gave you the wrong code. So you really have to go to their official documentation and get the code from there. So here you can see first difference, the major version. So let me just click on compare and see how does it look like. So here you can see that first is version, and then it is not providing you all these options: bootstrap, self-managed add-ons, and the cluster add-ons. This is how you need to declare for the new version, and this is the old version. That's where you are seeing that these attributes does not exist now, right? And after that, VPC ID and subnet IDs, it is not even providing those also. So all those arguments even change. Now for the manage node group. So let's see if it has generated the code for that correctly or not. So this is good, cluster version and all those stuff. And but this node groups, now it doesn't work like this. Like, you don't provide the node groups like this. And here you can see, I'm just providing minimum size 1, max size 2, and this. You don't have these kind of arguments now in the latest version. Here directly you are providing instance type, capacity, and all those things. So there is a significant difference with the EKS code, and that is the problem, that GitHub Copilot for the infrastructure as code is not reliable at this point of time. It helps you with some stuff but not for everything, and you really have to check their official documentation if there is any new functionality that was added for the Terraform resource, or if there are more options available. So my advice is to you that always check the official documentation and don't just rely on the GitHub Copilot code for the Terraform. Now we have our Terraform code for the EKS and for the VPC, and the next step is generate a GitHub workflow for that. So this is the one that I have created manually. Now we will see what GitHub Copilot provides for the GitHub Actions. Is it good, or is it better than Terraform, or is it worst? Let's explore this. So just click there and just see cd copilot.yaml. Now be specific with your requirements. So what we need, generate me a workflow which has pull request and push on main branch for CI CD, and do the Terraform deployment from the folder Terraform EKS underscore node group. Also use latest version of Terraform, and so this is all you can put it. And or you can just have a simple to start with, you can just have a simple prompt also. But as I already explore a little bit, so if you don't provide all the details, GitHub, you have to again and again provide the prompt. So let me just go with this and see what it does provide. Okay, so here you can see that it has provided me the CI/CD pipeline on the push branch and the pull request. So it do the CI/CD both. And here you can see Terraform deployment. It starts with runs on Ubuntu latest, and then steps, and the Terraform version it is using latest. And I set the working directory, so it set the working directory like this. But do you really like to set the working directory at every step? We wanted to have it at a global, right? We don't want to put the working directory again and again. So we'll update that. And the second thing, have you seen the code how this workflow is going to connect with the AWS credentials, AWS account? It has missed that step because we have not provided that in our prompt. So let's just do that again. So just click on this. Okay. So just click here and then put I need working directory to be set at global level, and use the AWS action to connect with AWS account. Actually, use GitHub action to connect with AWS account. Let's see what it will do now. Okay, so now you can see, let's just click on accept. So now you can see that it is default, it set that working directory is this, it sets the environment, and then it doing the checkout, configure AWS credentials. So here you can see that it has configured this, and this is where basically in the GitHub secrets you provide your AWS access keys, and then it is doing all those things. But here there is one thing. You can see that it just created the code like multiple times and just added on that. So you just need to do the little bit of refactoring once it has created all the code for you. So the final code basically looks like this mostly, where you have this and like this. So GitHub Copilot for GitHub Actions, I would say, is more accurate than Terraform code. It provides you all the details with the simple workflow. You will not see any issues with the simple prompt. You can just provide all the details and it will generate a code appropriate. But as I said, you always have to test your code and ensure that you cannot just rely on this code, AI generated code. You have to do little bit of fixing and debug it if it is perfectly or if it is actually as per your requirement or not. Okay, now we will learn some tips and tricks of the GitHub Copilot. So I'm just creating a new file like test.tf and we'll say what all other options we have. So this is we already learned that you have to provide all the prompt. There is another one which is the comment. Based on the comment also GitHub Copilot generates the code. So like I will say EC2 instance, and here you can see that it has generated the code. And if I go down and I will say security group, it will generate the code for that as well. It's not complete, but yes, I'm just wanted to show that it is generating the code based on the comment also. And just one example of ALB. So here you can see that it has generated the code and then it is automatically providing you that yes, you need ALB listener after that. So it generated the code for ALB listener and then it will automatically ask, oh, you need ALB target group also. So it is actually telling you that what all things is required for the load balancer, which is pretty good, which is good. But mostly we might not write the Terraform code in this way, but yes, it does provide you the basics. It does provide you, okay, what all things are required. Like instead of going to the official documentation, if you want to just play around with this prompt, you can learn things. But once you get the details, then make sure that you validate also. So that was the end of our video. So what we have discovered in this video, we have learned the strength and the weakness of GitHub Copilots for Terraform and GitHub Actions. We have seen that it works to some extent for the Terraform. It generates the code which works fine. But for some like EKS cluster, it just generated the very outdated code. So it is not reliable. And that is the reason for the infrastructure. It is not popular at this point of time. It will take some time because the problem is the Terraform providers, like it is getting updated very frequently. Like I mean every other day or every week there is some release, there are some new features added. And the Copilot, when it was it always have a old data of almost 1 or 2 years old data. So it is generating the content based on that. And as you know, the Terraform and all the mostly infrastructure tools, they 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 update so frequently these days. So you will have, so the main gap is requires manual updates and the verifications from your side. And I would say the best practices, cross check AI generated code for the best practices and combine the automation with expertise for the optimal results. So in my opinion, I use GitHub Copilot or the Chat GPT for the logic,
when there are some logic in Terraform you need it, it might help you, like when you have to use some for loop, some dynamic, it would help you. But for the actual code like EKS cluster, RDS code, I would still recommend you go to their official documentation of the Terraform providers and get the code from there and then tweak it as per your requirement. So I hope you guys like this video. Don't forget to share, like, and subscribe to my channel. And do let me know if you are looking for any of other videos related to the GitHub Copilot. Thank you.